Some of the equations we have appear to be quadratic in nature. And how would we solve those? Well, first of all, let's identify that it does look quadratic. Imagine that this also looks similar to maybe a 2u squared plus u minus 1 equals 0, where in this case u would equal cosine x. So I could solve that using a substitution and solve this for u and then plug back in what I substituted u for. In that particular case with cosine, if I did that, what is that? That's a 2u minus 1 times a u plus a 1 equals 0. And if I back substitute cosine in, that would equal 2 times the cosine of x minus 1 times the cosine of x plus 1. And that would equal 0. Some of you guys might be able to recognize and get from here to here directly without doing a u substitution, and directly we're able to factor that down to 2 cosine x minus 1 cosine x plus 1. If you aren't able to do that yet, because very few of you probably could, because it's just really, with practice, you might be able to. But that's all right. I want you to be able to recognize that this is a quadratic, and then go ahead and solve that in whatever best method that you have practiced at this particular point. So for this to be true, then I know that either 2 cosine of x minus 1 has to equal 0, or the cosine of x plus 1 has to equal 0. Solve that. 2 cosine x equals 1, cosine x equals 1/2, and over here cosine of x equals -1. So what value of x, where's my cosine? 1/2. That occurs at pi thirds. So x would equal pi thirds. Is one value. I know that cosine is positive in the first and fourth quadrant. So what's the fourth quadrant value of cosine being 1/2? And from there, it's 2 pi minus pi thirds. And that would equal, this is 6 thirds, 5 thirds, so that would equal 5 pi thirds. So there are my two values within the period from 0 to 2 pi, where I have a cosine equals 1/2. One occurs at pi thirds, the other one occurs at 5 pi thirds. And then from there, every multiple of 2 pi past that. So that's plus a 2n pi, and that's plus a 2n pi. The second one we need to check, we also need to check what happens in cosine of x equals -1. Where does that occur at? That occurs at x equaling pi. And then every multiple beyond that is x plus a 2n pi. So those are all the multiple values that I have. Then from there, I need to go back and restrict my solutions to solutions only between 0 and 2 pi. And so if n were equaling 1 in my first solution, pi thirds plus 2 pi extends it beyond the scope. The second one was 5 pi thirds plus a 2 pi also extends it beyond the slope. And likewise, my third solution of x equaling pi. If I were to add another 2 pi to that, that would extend it beyond it. So my solutions then are pi thirds from right there. My other solution is 5 pi thirds. And my last solution over here is pi. And so this particular quadratic trigonometric equation has 3 solutions within the interval from 0 to 2 pi. Solutions are at pi thirds, 5 pi thirds, and pi. Another quadratic we want to explore, or another wrinkle in it, is 4 sine squared of x minus 1 equals 0. All the values of x between 0 and, let's make that 2 pi. So let's solve that. Again, we want to get sine of x by itself. So we can divide both sides. Well, let's go ahead and do 4. Sine squared of x equals 1. Divide both sides by 4. Just some preliminary work. From there, we can take the square root of both sides. And so we would have the sine of x equals plus or minus the square root of 1/4. the two solutions, a plus or minus 1/4. If I simplify that, one solution is a positive square root of 1/4, which reduces down to 1/2, and the other one would be negative 1/2. So what are all my values of x, such that sine of x equals 1/2 or negative 1/2? What's that value? That was pi sixth. So x equals pi sixth. We know then that we have, that's the value in the first quadrant, the value in the second quadrant, where sine is also positive, pi sixth. We would find the second one by going to pi and taking away a pi sixth. And that's a 6/6 pi minus, so that's a 5/6 pi. Then we also have negative signs in the third and fourth quadrants. So to find the other ones, we would go to pi and add a pi sixth. That would equal 7 pi sixths. And the one in the fourth quadrant, let's go all the way to 2 pi and take away a pi sixth. And that would equal 12 over 6, 11 pi sixths. So there's 4 solutions right now. I found one solution in each of the quadrants where the sine of x is a positive 1/2 or a negative 1/2. And that occurs at here, 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 and here. And remember, there's multiple solutions to these every period, which in sine is 2 pi. So there'll be multiple solutions. So pi 6 plus 2 pi, 4 pi, and 6 pi, and so forth. But those are unnecessary to find because I'm only looking for the solutions between 0 and 2 pi. And if I add 2 pi to any of these solutions, that would take it beyond my interval where I was looking for it at. All right, how are you guys feeling? A little nervous? I don't blame you. And that's completely all right. But with some practice, you're going to start to see these a little bit easier and clearer.